Okay, so if we just scroll down what we've done so far, we did that solve for x there, and we kept on working with basic stuff that we should know number patterns, and I think we extended details. Then we went to functions, showed you how to convert such equations to a normal hyperbolic function. All right, and yeah, looking good so far. Dealt with this lovely function question as well. Now, to complete this, okay, we did all of this. Yep. Now, to complete this, we need to work around calculus. All right, so without wasting of time, um, let's quickly answer the following calculus questions. The first one talks about a first derivative. And I want to believe we all can derive. Do you want to try this for me quickly? I'll give you 3 minutes. Quickly. 3 minutes, derive that. 3 minutes. Answer that 8.1. It is 5 marks. Very, very important. Please answer the question. Let's derive. 4 minutes. Done with the full steps. We should be done. 1 minute. We should be done with all the steps. 6x should be our answer, but I'm expecting us to be done with all the full steps. Remember, it's 5 marks. Okay, everybody, um, quickly, can you send me a message? You are finding this challenging. Quickly, send me a message. Someone saying something? All right, let's quickly walk through this. We need pace. 45 minutes, we should be done with this section. Okay, so we need to write our f of x. I like to do mine this way. And what is x plus h? Then I replace my x there and simplify. X squared plus 2xh plus h squared minus 1, and that gives me 3x squared plus 6xh plus 3h squared minus 1. All right, so that's my building block. Now we need our formula. F prime of x equals to limit as h tends towards 0, fx plus h minus f of x over h. Remember that formula gives you your first mark. All right, then we say equals to, we keep writing limits. Don't get tired. What is my fx plus h? 3x squared plus 6xh plus 3h squared minus 1. Now minus, please don't. All right, can you hear me now? Good. Just changing this mic. All right, as h then tends to 0, not infinity. Okay. All right, so 3x squared plus 6xh, all right, minus 1 minus 3x squared plus 1 over h. There should be things that will cancel out. All right. Now, what do you have left? Limit as h tends to 0, h is common, 6x plus 3h over h. The h should also cancel out. Now we can remove the limit and say f. Remember, don't put a 0, it's wrong. It's not mathematical. H is not 0, becomes 6x. All right, so it's your 5 marks there that you should then get. I'm sure we all got this. This would be repeated over and over and over again. You know, it will be asked over and over again. All right, so that's done. Do you want to work out 8.2.1 and 8.2.2 for me? Let's quickly check. Here I'll give you 2 minutes, or let's say a total of 5 minutes. Work out the two. Work out the two quickly for 5 minutes. Are we winning, guys? Well, are we able to do it? Quickly answer yes or no. Which one is challenging? Quickly, I need to get your responses. Please, can I get your responses? Yes, Y for yes, and for no if it's difficult. Are you able to walk around this? All right. I need everyone. Guys, sometimes I don't, you need to just respond as fast as you can. It helps me to know the pace that I need to go with. Don't keep quiet when I ask for responses. Kaylee is quiet. I need to know. What's wrong with the second one, people? I think I even did explain this in the last session or something. The first one, y equals to 5x squared plus x to the power half. That's the only time you can derive 10x plus 1 over 2x minus half, because we're subtracting 1. I'm sure you know that principle. The second one is similar to it. It is, how would they mark this? Mark for changing that, mark for that, and mark for that. All right. Y, okay. You have that. 6x. Distribute or break it down. That's all you need to do. It's using your knowledge of fractions. All right. And this would give you 2. 6x over 3x would give you 2. Minus 4 over 3. Take the x up, because it is to the power 1. If you take it up, it becomes a negative 1. And you derive. If you derive a constant, it will give you 0. Negative times negative would give you positive. All right, so it's going to be 4 over 3 x to the power negative 2. And you are done. Talk to me. Talk to me. Did you get the steps? I need your responses. Once you see a fraction, split the numerator over the denominator. Simplify. Remember, do not leave. So the first thing is split the numerator. All right. Do not leave x as a denominator. Use your law of exponents. Such that 1 over x is the same thing as x to the power negative 1. 1 over x squared is the same thing as x to the power negative 2. 1 over x cubed is the same thing as x to the power negative 3. All right. I should repeat. This is what we did. I'll repeat quickly. we split the numerator. I still have my instruction derived with respect to x, 6x over 3x. This is using your fractions, LCD. Now, simplify. What is 6x divided by 3x? The x would cancel the x, 6 and 3. All right? 6 divided by 3 would give me 2. Minus 4 over 3. That's a number. Don't worry yourself about the number. Worry yourself about the x. Do not leave x as a denominator. It's x to the power 1. It goes up. Now you can derive dx equals to 2 is a constant. When you derive a constant, you'll get a 0. All right? You'll get a 0. And then you'd have minus times minus with a positive. So you have 4 over 3x to the power negative 2, because you subtract 1 from the exponent. And to answer Lesedi, this is also equal to 4 over 3. If I bring the x to the power negative 2 back down, it becomes x squared. These two are the same. So if the examiner says leave your answers as positive exponents, you write the one in yellow. But if there is no specific instruction like this case, you are free to write your answer the way we have the top. Please talk to me now. Are you okay, everybody? Did that make sense? And this you would get a lot. Talk to me. Are we okay with this? We should be okay with this. We should be very okay now. All right. Look at the next one. Look at the next one. Given s of t is t cubed, show that the gradient of any tangent to s. Look, I want us to understand the language. Don't just read. If you notice, I always read emphasizing words. Show that the gradient of any tangent, all right? The gradient of any tangent to s will never be negative. When they talk about gradient, what is it that they are referring to? F prime of x. We've spoken about that. And that should be equal to m. All right. So if I then have s of t as t cubed, what is my first derivative? S prime of t. We are deriving with respect to t. It will be 2t squared. And this is equal to the gradient of the tangent. All right? That is equal to the gradient of the tangent. Mathematically, look, t squared will always be greater than 0 for any value of t. Anything you square will be positive, any value of t. Therefore, gradient, which is 2t squared, will not be negative. So remember, the language is what's important. We derive, and then we know with mathematical principles that anything you square will always be greater than 0. Anything you square will always be greater than 0. Yes, somebody calling, Lesedi? Three. Easy, easy, tiger, easy. All right, are we okay? Are you okay now, Lesedi? Yes, sir. Okay. All right, so guys, that's how to answer your question. Let's look at the next one. Cubic graph. The sketch below shows the graph of a function x cubed minus x squared minus 8x plus 12. A is the x-intercept and B is the turning point of the graph. The graph C0 and 12, D2 and 0, the other turning points are given in the sketch. This is very straightforward. Look, without even going to what the question is, can we quickly find the value of A? Do you think we can get the value of A? Because I'm sure determine the coordinate of A and determine the coordinate of B. That is very, very straightforward. You can use whatever method that you know, synthetic maybe. All right, value of A. Let's find the value of A. Or can I ask you to quickly try that? Find the value of A. We're solving. I'll give you 3 minutes. You shouldn't use more than 3. 3 is too much, but I'll allow you to use 3 because I want us to be the ones doing the work. Once you are done, put in your answers quickly. 3 minutes. Come people, we need to work as fast as we can. Sophie's given me -4 and 0. I need to confirm that answer. We should be done. We should all be done. This is how to deal with exams now. Time is part of our exam. we're looking for the coordinate of A. All right, so there is a problem. I have two different answers. I have three different answers. My God. X equals to negative 3, x equals to negative 2, x equals to negative. Please, everyone, please check again. I don't know what is correct. And I can simply check what is correct by substituting your answers in f of x. One way you would know whether you are correct or wrong. Now, Sophie, substitute x as negative 4 in f of x. If you get 0, you are correct. Mduduzi, substitute negative 2 in f of x. If you get 0, you are correct. Lesedi, negative 3. Someone must be wrong. Or two people are wrong, maybe. Come. I need the correct answer. And I'm waiting for Deshni. I'm waiting for Sine. Kaylee. I'm waiting for Snate. Pumelelo. Tunsani. I'm waiting for Lesejo. If negative 3 is correct, then I need Mtuduzi and Sophie to fix it. I need you guys to quickly fix it. This is marks that we are not going to allow ourselves to miss. Sophie, did you fix it? Others that are refusing to talk to me, if you're not giving me your answers, I'm just going to move on to the next question. I promise you I'm not going to do it. And at exactly 6, we move to physics. I need answers. I need to know if you are okay or not. Why are you getting negative 2? Already they told you that x equals to 2 is a factor from G. So if you are using the synthetic method, you write the coordinate of x cubed x squared, that, and that. Now 2 would go in there. We drop this value, that gives us 1. We multiply, 2 times 1 would give us 2. We add, negative 2 minus 1 would give us positive 1. We repeat the process, multiply, that will give us a 2. 2 minus 8 would give us negative 6. We'll repeat the process. 2 times negative 6 would give us negative 12, and we must have a 0. Now we write this out. This becomes x squared plus x minus 6 equals to 0. And we factor out x minus 2, x plus 3. So x equals to 2 or x equals to negative 3. Done. And already you have your x equals to 2 here. So this one has to be a negative. So x is negative 3. Guys, this is where we save time. Things like this is where we quickly save time. So the coordinates of A are negative 3. Remember, the examiner wants the coordinate, and 0. That's it, guys. We save time here. All right, Deshne, I need to move to the next question. We just have a few minutes. All right. Coordinate of B. What is B, by the way? B is the turning point. All right, which means we can quickly find the turning point. F of x is x cubed minus x squared minus 8x plus 12. Do you want to derive for me quickly? Turning point. You derive TP. Okay, I'm going to do this because of time. You need to practice. And we make sure that that is equal to 0. Now we then try to find factors. I'm going to do my own method. That is 24, 6x plus 4x minus 8 equals to 0. I might have shown you that method when we're still looking at question 1. And I have 3x is common, x minus 2. I have 2 is common. I have 4 rather. 4 common. I have x minus 2 equals to 0. What is common? 3x plus 4 now. I have x minus 2 equals to 0. 3x equals to negative 4. X equals to negative 4 over 3, or x equals to 2, which makes sense to me. If I take you back, you would see when I say it makes sense. My graph is turning at x equals to 2, which is point D. That's the turning point, and we have a 2 there. It means the B value of x is negative 4 over 3. Now, how do you, because the examiner wants the coordinates, how do you get the y value? You take your x and substitute in the original function now. So take your x and substitute. That's how we get y. So y will be negative 4 over 3 cubed. And I want answers as fast as possible here. Please don't forget the negatives, especially when it is repeated. Minus 4 over 3 squared minus 8 times negative 4 over 3 plus 12. Do you want to give me an answer? And if you are lost, you need to let me know. Can you hear me now? Can you hear me now? All right. No, I didn't switch off. I didn't charge my mics. So just keep changing. All right, but that's just it. Like I was saying, this one here is not in your syllabus, but it's applicable. Just for me to quickly know my answers. All right. So we don't need to stress over this. Don't even use it. But at least it's an extended knowledge for you. Don't use it in an exam, because you would forget and mix it up. So please don't use it. All right, let's quickly answer the questions. I think 10 minutes or so, we should be done. What do we have? Point of inflection. Oh, what do we know about point of inflection? So you need to know all of this characteristic. Point of inflection, we know that the second derivative should be equal to 0. Now, I do have my first derivative as 3x squared minus 2x minus 8. Now, what is my second derivative, which should be a straight line? 6x minus 2. And that should be equal to 0. So 6x equals to 2 over 6. X is 1 over 3. All right. That's very easy. 9.3, done. You know, you don't have to waste time. 9.4. Write down the values of x for which f prime of x is greater than 0. There are two ways to do this. You can use the graph or you can use your equation. Wait, let's try something. Let us use our equation first. Remember they said f prime. So I want to solve this in two ways, either by algebra or by my graph. Look, the examiner is telling you this. They are taking you back to inequalities. We had, what did we get here? We had, let me go back quickly. Let me run back. What did we have? 3x plus 4 and x minus 2. I hope I'm still with you. 3x plus 4. I'm not even going to waste time. Your critical values, you know now, is negative 4 over 3 and 2. If you remember when we did this, I told you that your x would be bigger than the bigger critical value, which is 2. And x would be less than your small critical value, which is negative 4 over 3. Those are my answers. However, should I want to use my graph, what will I do? I hope, look, solve algebraically is okay. Should I want to use my graph, look at what I'm going to do. I like to interpret the graph. Where is the graph? Okay, here we go. Now, what do they mean by f prime of x? We've mentioned that earlier on. X prime of x is the gradient. Okay, so examiner is saying they want to find out. Look, they are simply saying, where is the gradient? Oh, my spelling. Gradient. Where is the gradient greater than 0? Basically, where are you having a positive gradient? Gradient is a straight line. Check here. The gradient here is positive. I'm going to draw so many lines, so please follow through. The gradient at point B, these are the strategic points. Gradient at point B, would see what that gradient is. Don't get lost. I'm going to interpret all of this gradient. Gradient there, along that line. Gradient here, and gradient there. Now let's do analytical. The first gradient, this is a positive gradient. I'm sure you remember analytical, positive gradient. M is positive. Here m is 0, turning point on that gradient. What about this one slanting to the left? M is negative. Here, m is 0. This is you understanding properties of gradient, and m is positive here. So the examiner is saying, where do we have the gradient as positive? Do you notice, where's my highlighter? First, gradient is positive all around. Let me draw a box. Where is my gradient positive? The gradient is positive here, and it continues. All right, I hope you see the box. And the gradient is positive here from 2. So the gradient is positive from 2 to the right. Gradient is positive from, we have that as negative 4/3 to the left. I hope you have seen your answers. These are the points where my gradient is positive. So x is less than negative 4/3, or x is greater than 2. I need you to be able to use the graph and also do it algebraically. So remember, f prime of x refers to gradient. F prime of x refers to gradient. I love this. I love this. Guys, talk to me. Are you okay with what I explained in terms of the graph? Are you okay with what I explained in terms of the graph? Because you need to be able to use the graph. Can I get your responses quickly? I only have 2 responses. I want more. I want more. All right. Okay, that question is done. How many real roots with the equation? Look at this. Let's interpret this. How many real roots with the equation x squared minus x cubed minus x squared have if k is less than 0? All right, if k is less than 0, let me use the same because we're using the graph. How many roots if k is less than 0? A lot of learners don't know how to interpret these roots, and I think I did this as well, yes, when we're looking at paper 1. And I told you that roots can be interpreted. One of the interpretations we can have is your x-intercept. If you remember that, you are going to be moving towards getting the correct answer. All right. So one of the ways to interpret your roots is to say your x what? Intercept. Now, but the examiner says that x cubed minus x squared minus 8x plus 12 equals to k, and they want k to be less than 0. Wait, this whole thing is your f of x, and your f of x is y. Oh, so they are saying y should be equal to k, however, k should be less than 0. Oh, y should be less than 0. I have interpreted. Watch what I'm going to do on the graph. Y should be less than 0. This equation here, or this line here, is y equals to 0. If I want my y to be less than 0, I need to drop this line below the x-axis. Now, y is less than 0. Anywhere below the the x-axis shows me that my y is less than 0. The question now is this: How many times does my graph cut the new x-axis, which is the red line? How many times will it cut the graph? That is the root of the equation. How many times? Just once. So how many roots will it have? Roots will be 1. 1 root. I don't know if we are okay. This is how you interpret the question. You just move this. Where will it have 1 root again? Let me show you another spot where it will have 1 root. It will have 1 root here. Should the examiner ask you again, where will it have 1 root? It will have 1 root there. Do you know why? Okay, this graph continues, right? Let's use a black one. This graph does continue. It will have 1 root there, where y is greater than 500 over 27. I hope you remember that value. Again, when y is greater than 500 over 27, we would have 1 root. I'm going to stay, let me stay here a little bit. I want to stay here a little bit. What about here? I want you to see something here. Good. Here. Watch this. It has 2 positive and 1 negative roots. 2 positive, I hope it's making sense. 2 positive and 1 negative root. Between where and where? Please listen carefully. Between C, the y-intercept, and D, anywhere here. Do you see that? All right, once I move here, it cuts the graph 2 positive on the right and 1 on the left. What would my answer be here? My y will be between, my y value there is 12 and my y value there is 0. So when my y value is between 0 and 12, I will have 2 positive and 1. I hope it makes sense. If you are lost there, hope. If I want 2 negative and 1 positive, 2 negative and 1 positive, that will only happen between B and C. I hope you see it. Between B and C. After C, I'll have 2 positive. So 2 negative and 1 positive between B and C. Y is between, which one is the small value? 12 and 500 over 27. I wanted to just extend that information. Please talk to me if it's okay. I know this might be a bit hectic. I don't mind re-explaining because I want you to get this. Please talk to me. Talk to me. I need you here. This is playing with number of roots now. Number of roots. Please talk to me. I need you. I need to hear from you. I'm waiting. I'm waiting, guys. I'm only having 1 person, and if it's 1 person, I can just do that on a phone call. If we get it, we just need to move forward. If it's 1 person, I can always do that on a phone call. How many roots do I have here? 1, 2, 3. Do you see here I've got 2 positive and 1 negative? That we are looking at where the x-axis is touching the graph. If I want something else, I'm going to use different colors now. Watch this. Here, how many times are we touching the graph? Just once. It means I have 1 root. What is the nature of this line, or what is the equation of this line? Y is less than 0. The same thing happens here. Above here, how many times am I touching the graph? Once. What is the equation of this graph? We know this point as 500 over 27. So y is greater than 500 over 27. How many roots do we have? 1 root. It's just 1 point of intersection. Now, examiner says where we have 1 negative root. My graph is a bit skewed. I'm just going to try to maneuver this graph to look like what we have exactly. All right. And that point is 12. Okay. This point is 500 over 27. I'm going to take this up a little bit. Yes. Because I want it to touch the graph just once. Now, if I want 2 negative and 1 positive, take a line, take a ruler, and remember, I'm looking for 2 negatives and 1 positive. How many times? Yes, just once, and it's negative. All right, here on the left. All right, I'm going to go on. Now we have 3 points. But if I move on, all right, check here. If I move on, what do I have? I have 2 positive values of x and 1 negative value of x. Oh, if I move on again, what do I have? 2 positive and 1 negative. I'm going to keep moving. What do I have? I'm using color code. 2 positive and 1 negative. If I then move on up until somewhere here, it stops right there. All right. So if I want 2 positive and 1 negative, it needs to be below that point there, below 12. Do you see below 12? That 2 positive x values and 1 negative. All of this is giving me 2 positive, 1 negative. And what is my y value there? My y value there is 12, all right, between and 0. I'll have 2 positive and 1 negative. Remember, I am dealing with y values between 12 and 0. 2 positive, or I should actually say that, because at 0, I'm having 2 positive values, which is 2 there. Remember, the x value there is 2, and that's negative, so 0 is included. But if I want 2 negatives, let's use a different color. Let me use blue. Again, my x there, you see? 2 negatives and 1 positive. That's what I have. 2 minus 2 negative roots. That again would continue. 2 negative roots and 1 positive. That will until the turning point, because at the turning point it's also inclusive. We have 2 negative values there. All right. So what will my answer be? My answer will be, we're looking for y. What is the smallest value? 12. Biggest value? Less than or equal to. I have 2 negative, and 1 positive. I don't know if you are okay right now with this explanation. This looks very lovely. 2 negatives and 1 positive. 2 positives and 1 negative. Talk to me. Did it make sense now? I need to move on. We're already eating the next session time. Two positive, 1 negative, 2 negative, 1 positive, 1 root, and we refer to y values. All right, thank you. It makes sense. This is very, very important to be able to deal with. Awesome. Remember, don't forget the equation already told you that f of x, we know that f of x, they're saying k, but we know that they are referring to y value here. All right, so y is k. That's what we are referring to. Quickly, let's finish. We have this other question here, which is an application question. All right. Application question. PQRS is a rectangle with P on the curve h of x equals to x squared. And there's something I want to quickly teach you here. I want to teach you something here. All right. With the x-axis and the x equals to 6 as boundaries. Okay, we've checked. Look, show that the area of the triangle, all right, can be expressed as that. Guys, if you are having challenge to do it, this paper is already on the group. The paper is already on the group. It was what you're supposed to do on Tuesday or on Monday. All right. If you are finding it difficult to do the first one, look, you can start with the second one. Sophie, you had a question like this. I want you to check something. It says, show that the area of the rectangle. So this A is area. Look at the next question. Determine the largest. The word largest means maximum. Possible area. Oh, they are referring to that. And when you see the word maximum, what do? You derive and make it equal to 0. Which means, guys, I can start from 10.2 before I do 10.1. If I'm not sure of 10.1, 10.2. My area is 6x squared minus x cubed. They want the maximum. It means I need to derive dA dx. What would that give me? 12x minus 3x squared. And make sure, since it's maximum, that must be equal to 0. 12x minus 3x squared equals to 0. What's common? X. 12 minus 3x equals to 0. It's either x equals to 0 or 12 minus 3x equals to 0. 12 equals to 3x and x equals to 4. This one is not applicable because a rectangle cannot have a 0 measurement. All right, so x equals to 4. Do you see what I've done? I have actually done 10.2 with the help of what they asked me to do in 10.1. This is should I be struggling with 10.1. It's not the end of the 7 marks. I still got my 4 out of 7. Now let me go get the 3 marks. I hope it makes sense. Now let me go get my 3 marks. Coming back now to get the 3 marks. Let's see. How do we prove the area? Okay, it's functions. We want the area here. Let's use red. But I know that it's a rectangle, so area is actually length times breadth. Let's find what the breadth is. Wait, this is the x-axis. It means this is x. That is 6. It simply means that QR is 6 minus x. I don't know if that makes sense to you. That point Q is x. It's on the x-axis. R is 6. Also, QR is 6 minus x. Because this is x and the rest is 6. So the difference. What about the height or the length here? Okay. What about the length there? Wait. The length here, since this is x, what is the value there? Oh, this function is x squared. By the way, y is x squared. Oh, so if this is x, this whole length here is x squared because that is my y value. So it means PQ is x squared. What is area? PQ multiplied by QR. What is my PQ? X squared. What is my QR? 6 minus x. Let's expand. What are we going to have? X squared times 6, 6x squared. X squared times minus x cubed. Done. You get your 3 marks. All right. But I hope it makes sense. This is using your knowledge of functions again, knowing that f of x is equal to y. All right. That's our mathematics done. All right. Everything we've done for term 1 and term 2 for paper 1 has been done. It's time for physics now. I hope this is okay. Guys, quickly list